Okay, get the program cooperating in. Cold, high pressure. What would happen if things get warmer? Well, what happens to ice when it gets warmer? It melts. So the hydrates will break down if they get too warm. But natural gas, methane, it's a strong greenhouse gas. It traps heat quite effectively. So put more greenhouse gases into the air if these ices break down. Okay, more greenhouse gases. It'll get warmer, which will break down more of the gas hydrates, releasing more methane, which makes it warmer. We've got a positive feedback loop going. This can potentially cause somewhat rapid warming if it gets started. Of course, this stuff bubbling up, probably not the greatest thing for going over it. This is a map showing areas known to have gas hydrates along the coast. Quite widespread. And realistically, these are probably largely where somebody's looked. The places that do not show it, there's a good chance that more of these places have them, it's just that nobody has checked. One other thing on here, this X up off of Norway, is a spot where, as you can see, there's gas hydrates there. And there's this big underwater slump. Ice attaches things together. If the ice breaks up, the sediment that was held together by that ice may become unstable and fall down. And so that X shows a spot where you had a large scale, basically a landslide, underwater, but landslide sort of thing, that happened because of the breakdown of the gas hydrate that was holding it in place. Big underwater landslide, you suddenly change the bottom of the ocean, that tends to make a tsunami. And indeed, not only do we have the slump there, but we have where a tsunami washed over things like the Shetland Islands and northern Scotland and places like that in the area. So this can potentially be a significant hazard for tsunamis. You'll notice another place that has plenty of gas hydrates is our coast. There are places along the edge of our continental shelf where there are slumps seen to be associated with gas hydrates breaking down. How catastrophic were they? Did it happen suddenly and make a tsunami? Or did it just sort of slowly slide down and just kind of make a mess down by the ocean? Hard to tell in many cases, but it's definitely something that we want to be aware of, especially warming temperatures may make breakdown of the gas hydrates more likely. Another important type of resource that can be obtained from the seafloor are things like sand and gravel. Now, of course, bucket of sand, ton of sand, generally doesn't cost that much, but we use huge amounts of them in construction, making roads, buildings, concrete uses sand and gravel, things like that. It's actually to the point where there's major black market for sand, more developed countries buying up the sand from developing countries so that now there's no beach or things like that causing environmental damage. Sand, gravel, those will tend to be places where we've got stronger water movement, so that washes away the small silt clay stuff, and we just see sand and gravel things. Okay. Strong wave, tide, current effects. That tends to be in shallow water. But Where shallow? Depends on sea level. Ups and downs, build glaciers, that's less water in the ocean, sea level goes down. So we have places that are now deeper that were shallow, back ice age, things like that. So we get places here and there with sand and gravel on out across the continental shelf. Again, heavily used in construction. Also a popular source of sand used for beach renourishment. Again, as we saw before, you dump sand on the beach because the old sand washed away. Guess what the new sand's going to do? Wash away. Also, you're making a big hole somewhere in the bottom of the ocean, messing that up for what used to live there. You're smothering the beach with the new sand, messing it up for the stuff that lived there. Not so great environmentally, but it means your beach house has more sand from again. Digging down under the water tends to stir up a lot of mud, so you've got problems there as well. Here's a map of areas with sand and gravel known along the U.S. continental shelf. You'll notice suspiciously straight lines between these areas. No, sand does not stop at the Virginia-North Carolina state line. Pretty obviously this is where people have looked for it, as of whenever this map was made. Now, it is true that, say, off Mississippi, it's pretty muddy in there, but there are sand and gravel areas along much of the continental shelf. There are also particular minerals of value found in the ocean, often somewhat deeper down. For example, areas of the abyssal plains have extensive covering of manganese nodules. As the name implies, they are rich in manganese, also iron, nickel, various other metals as well. And of course, these days, technology, we use all sorts of different metals in a wide variety of ways. So these could be quite valuable. And as this picture shows, they can be abundant on parts of the deep sea floor. But there's a problem. Getting to the abyssal plain and back is not easy to do. You're under a few kilometers of water. Not the simplest thing to deal with. We also don't know much about the life down there. What effect on the environment will it have if we start mining these? So those are a couple of difficulties there. There's also a legal issue. Out in the abyssal plain, a lot of this is international water. So officially it belongs to everybody, and everybody's going to want a piece of those profits. So you have some legal logistics there to think about. There was one very highly publicized effort to try to mine manganese nodules, or at least that's what the CIA wanted you to think. And the Soviet Union had a submarine attempting to spy on the US by putting it over towards Hawaii, and something went wrong and the sub sank. This made some noise. We actually had better data on where the sub was than the Soviets did. But they'd be kind of suspicious if we suddenly had a bunch of Navy ships running around that area. So this scheme was developed to have somebody announce that he was setting up a company to try to go bring up manganese nodules and sell them for the metal value. And they actually did locate the submarine and get part of it up, but it broke, and exactly what all they got is still somewhat classified, but most people think that they didn't actually get much of strategic value. Also, it wasn't a big success in terms of marketing manganese nodules because they weren't really after them. Cobalt, another valuable metal. Cobalt tends to concentrate in crust forming down about a kilometer, 2.5 or so, along the slopes of volcanic islands, seamounts, things like that. Cobalt, when you add some of that to your steel, it becomes much more strong at high temperatures, under conditions of high friction, things like that. It's used in batteries, other industrial chemical uses, so of value. We don't have much of it on land in the US. The main producing region is in Central Africa, and if you're familiar with the political situation in especially Democratic Republic of Congo, it's not good. You've got long-running civil war with most of the neighboring countries involved as well, and so it's relatively dangerous, difficult to get things quite a mess there. So alternative sources certainly have their appeal. Phosphorus, it's part of cell membranes. It's in DNA, so all life needs it. And some of us, like vertebrates, also use it in our skeletons. Our bones are calcium phosphate. So living things need a decent supply of phosphorus. It's not always abundant in the soil where plants would need it. So it's an important part of fertilizers. Under the ocean, areas with high surface productivity, like areas with significant upwelling, will tend to get a lot of phosphorus being deposited in somewhat deeper areas, like, maybe not extremely deep, but say 100, 200 meters mid to outer shelf areas. Dead stuff, waste, sinks down, gets buried, and chemically, over time, you get concentration of phosphorus into these lumps and things like that. Most phosphate mining is areas that used to be like that, but now are up on land. For example, east end of North Carolina, the town of Aurora has a major phosphate mine. These build up slowly above the ocean. We use lots of it, mainly for fertilizer. Now there's a tendency to just dump loads of fertilizer on your field. A bunch of it washes away and causes problems elsewhere rather than being useful. So one thing we could do is be more efficient in our use of phosphate. But it is in other things as well. Baking powder, a number of sodas. If you see phosphoric acid in an ingredient in your soda, there's a good chance that came out of the ground in Aurora. They have the facilities to process it clean enough to be approved for food. A few decades worth of material known on land. Again, you've got political issues. One major producing area is in, well, depending on who you listen to, either Western Sahara or Morocco. Morocco claims Western Sahara. The locals tend to want to be independent. So you've got some problems there. These deeper water mineral resources are just starting to be used. A mine has been approved off of Papua New Guinea at a hydrothermal vent. But hydrothermal vents tend to be rather local, patchy settings. There's definite concern that this may put the creatures that live at the vent at risk if you have mining there. There are a number of applications in the works, and in some cases, testing to see if an area might work for mining looks an awful lot like actually mining. So this is something that's beginning to happen.